Hey everybody, this is Larry, this is me going with Q4 of the bi-weekly contest 111, number of beautiful integers in the range. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this problem. So this one, there are a couple of things for sure. I think we did a similar problem on a contest 2 or 3 weeks ago, maybe something like this. But the core idea behind this one, there are a couple of core ideas, but the core idea about this is dynamic programming on what people call digit DP, which is you do it digit by digit, right? So basically, first of all, you're trying to find numbers in a range. So basically, the idea here is that you have some, if you're trying to calculate. You can think about it as prefix sum, right? So basically, let's say you have, a binary Boolean thing of whether, this is 0, 0, false, or this is false, false, true, false, false, true, like for each other number or something like this, right? So that's basically, this is just me banging on random thing of whether a number is, f of, let's say f of x is equal to this for some sequence, then now the prefix sum is going to be just 0, 0, 1, 1, 1, 2, 2, 2, 3, 3, something like this, right? So it becomes like a prefix sum sequence, and from this kind of sequence, and to get the number of, total within 2 indexes or a range, it is just equal to so to get f of to get the count between low and high inclusive, it basically becomes f of high minus f of low minus 1. Oops. Because you can see that because f of high is just equal to, say, whether I'm just going to write g for good, but g of high plus g of high minus 1 plus g of high minus 2 ... plus g of low plus g of low minus 1 plus ... plus g of 1, right? And that's basically whether the g is maybe the number if it's beautiful or not, right? So that's basically the idea. And f of low minus 1 is going to be a lot of these things here. And so to count the number of beautiful numbers from low to high, if you subtract these, everything cancels out, and you have this, right? Just want to go over this really quickly. Yeah, I just want to go over this part fairly quickly. I'm not going to go into more detail here. So I'm trying to wonder what's going on with my notebook, but yeah. So now it is still So how do we get f of an x, right? That's basically the way that we have to. That's just the problem now, right? Yeah, so that's basically the problem is that now how do you get f of x, because then now you could just do the other two things. Well, the short answer is that because x can be some number, right? So x can be some number with a prefix. Let's just say it's, I don't know, I'm just banging on the keyboard, so that's not even enough digit, right? So let's say this is the x is equal to this number. Then the idea here is to just kind of get the total in a way, right? So the way that I usually do these is by breaking into a couple of different functions. You don't have to quite do it this way. In fact, I think the way that I'm doing it is slow for contest time, because I'm very deliberate. Usually going to be right, though I got 2 wrong answers for stuff that I'll show you in a second. But yeah, I think it's easier to explain, and it's the way that I solve it nowadays. But maybe I need to do it a little bit faster for contest speed, but that's besides the point. But the idea is that I break into 2 components, right? The first component is Yeah, so I think I have something called h of x, which I don't know, the naming is terrible. But basically, the first thing I do is, okay, I go, okay, let's say x has, in this problem, it doesn't make sense per se, and we'll go into y in a second, but we go x is equal to 1 digit, count for 1 digit, 2 digit, 3 digit, dot dot dot, all the way up to 5 digits, right? I guess I could have just typed it out because this number has 6 digits. That's why. And then now, so f of x is equal to total of this plus where x is equal to 1. So 1 prefix. So this is saying the first digit is 1. But yeah, so basically this is saying the first digit is a 1, and then now you have 5 digits left, and then 3 5 digits. 3 being you can do whatever you want with them, plus a 2 and 3 5 digits. Of course you should cache these, but we'll go in. Plus dot 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 all the way up to, because this is a 6, we say 5 with 5 3 digits, right? 3 5 digits. So it's this plus x being the first digit is a 6. Well, if the first digit is 6, you don't have 3 5 digits. You actually have, well, what is it? Well, you do it recursively. You go 6 and then 5 digits, 5 constraint digits maybe? I don't know. Digits, right? Which basically goes up to 6 and then a 0 with 3 4 digits. 6 1 plus 3 4 digits plus 6 2 3 4 digits dot dot dot, right? All the way up to 6 8, and then you have 4 constraint digits, and then so forth. I mean, you could see the pattern, but that's the way that I break it down into solving these, and yeah, that's basically the idea around solving it. Yeah, so that's basically the idea behind this. Yeah, and so for every one of these things, I have a function for it, and that's how I solve this problem, right? So yeah, let's go over each of these then, right? So what is the count for 1 digit? So the way that I think about these, or for x digit, or d digit, say, right? The way that I think, so this is where the problem gets its name from, digit DP, is that you do it 1 digit at a time. So basically you brute force, in a way, the current digit and states that have similarity, right? So basically for this particular problem, the way that I define my thing is that, okay, for d digits, we have a function that just say, I don't know, naming things is hard, right? So yeah, so I think I just, what did I call it? I think I just call it go, maybe. Yeah, I call it go. So I'm just going to say go. Well, like I said, naming functions is hard, so you have to figure it out. But basically, it has d digits left. So actually, in this part, let's just go over the code. Yeah. Basically, let's go over the code. So this is my f of x. So total is equal to 0. We just have to sum it all up. But and here we go, okay. So this is what I call free I digits, right? So basically, this is any number of with I digits. Yeah, sorry, I'm trying to phrase it quite correctly. So you have I digits, and these are all free, and that you have no issues with them. So then now we brute force, 1 digit, 2 digit, 3 digit, dot, all the way to d minus 1 digits inclusive. Of course, we only care about even digits or even number of digits for a reason we'll go over in a sec. But yeah, so we'll go over this now. So here is the number of digits. If we have odd number of digits, we return 0. The reason is because the problem constraints, right? You have to have the same number of even digits and odd digits, and you need a even number of digits for that, right? Total number of digits. So yeah, so we have total is equal to 0. We just set the sum. This is half the number, so half has to be even and have to be odd, and basically that's it. We have to go to go, and what is the state for go, right? Oh, it's right here. So basically, given left digits left, we have even digits left and even digits left and odd digits left, and current mod is mod, right? Basically, that's the idea behind this one, and this is the core. One big core part of it is that now, and one thing to notice is that odds is just equal to the number of digits left minus evens, right? That's basically, and I have it here so you can kind of see it. Hopefully that makes sense because we don't have any other types of digits. And then yeah, and we have no digits left. This is the base case. Then we have to make sure that evens is 0, odds at 0, and mod is equal to 0, meaning that it divides k evenly. Then we return 1. Otherwise we return 0. Otherwise we just brute force, like we said, the next digit. If it's, if it's an even number, then, and we have evens to use, then we do this. If it's an odd number and we have odds to use, then technically it's odds minus 1, but that's factored into left minus 1 minus even. And this is just the shift and add, right? So this is shift and add. Not going to go over shift and add, but basically, maybe I am going over anyway. But basically, you have the current, what's it called? The current mod, the current leftover, the current remainder. Let's say we have 1, then basically what this is saying is that now we have to times it by 10 and then add it to the digit. So we shift and then we add. I just write an I don't know. Yeah. And that's pretty much it. So this is the function for this part. And hopefully this part is understandable. If not, this does come into play a lot. So you definitely should try to figure out. Yeah. And yeah, and so that's the first part of the number 3 digits, and then the second part is what we said, right? Is we go over the prefix, which is all these parts, right? So we did it for all the smaller number of digits, and then now for this part, this is just saying, okay, the first digit is I, then now, we just factor that in, and we can go straight calculate because everything else is free, right? When I say free, it means that it's unconstrained. You can do whatever you want, and this calls go for that reason. Otherwise, if it is constrained, we have another function that we have here. We just care about the suffix, so that's why I kind of did this weird thing for. I think the way that I write this is a little weird. I'm not gonna lie, but this basically lets you do the suffix of this, and yeah. And what does this do, right? This is basically saying that. Given we have suffix x left to handle odd digits, odd digits, even digits, mod left over, and then you basically return the count, right? And again, the base case is exactly the same, is that if you have no more digits left, and you have just one if the conditions are met, otherwise I return 0. Yeah. And then here we brute force the first digit again, and this looks exactly the same as here. Yeah, I guess I could have just actually written something like this. Now that I look at it. Yeah. And maybe that should be right, actually. So then you don't have to look at it multiple times. But it's still basically the same idea. Okay, maybe not. I don't know. Maybe I'm considering something weird. Why is that wrong, actually? I don't know. This is the right one, so we'll just keep this for now. I don't know why the other thing should be right, but maybe I don't know. All right, but yeah, but basically for this function, like we said, we just can't brute force the first digit, right? And if the first digit is less than, for this example, we only go up to 60. Like if the next number is 8, we only go up to 6 plus 6, 7, 3 digits or 4 digits, right? Because it can be any numbers on the, when I say 3 digits, it means that, it can be any numbers plus the recursion of this being the first digit and 4 constrained digits, right? So that's basically what I do here, except for that it's right here. Except for that I, just do if statement to see if the current digit is odd or even. Yeah. So that's basically the core of this problem. This is kind of a copy. But yeah, the reason why I got 2 wrong answers, I'm really sad about it, is that I did copy paste this here and do this here, and then I just forgot to shift and add part twice. So that for 2 wrong answers. So that was really silly. Yeah, I don't know. But yeah, that is very silly. I'm very sad about it because that 10 minutes is a lot of penalty. Because without those, and yeah, without that 15 minutes, I would have done like much better. But in any case, yeah. So what's the complexity? Well, we called this number twice. So yeah, and so this function, we only call it twice, and this has a loop of up to 10 digits, right? 10. That's up to 10. That's up to 10. So this is O of D, right? D is the wrong word. So D is the number of digits, but also times A, where A is the size of the alphabet, right? Yeah, D is. And by the size of the alphabet, I mean 10, right? Like from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And this is D times the complexity of H, and A times complexity of, I did, yeah, of these other things, right? So let's just call it G maybe, right? Roughly speaking, yeah. Or Go, I guess technically, plus G. Right, so that's the complexity of this. And what's the complexity of here then, right? Well, G of the complexity here, we have, okay, X has D number of possibilities, because this is just a suffix. I wrote this a little. I used the string as a suffix, which is probably not in good form, but yeah, it only has d number of possibilities. Evens only also has up to d over 2, but I'll just write d as well. And mod is up to k, right? So that means that this complexity is going to be d times k, number of iterations. And each iteration, we do at most 10 numbers, right? We do, this is at most 10, and this is just at most once. So that means that it focuses on this. So it's this times go times a times go or something like this, right? Something like that. And then this function. But keeping in mind, sorry, maybe I lied here. In that, keep in mind that these functions are all of 1 because we cache it. So we can actually just, reduce this. It's all one kind of. We'll talk about that in a sec. So that's basic complexity for these. And then for this function, again, left only goes up to d, evens only go up to d, and mod only goes up to k. So this is also d times k times a again for the size of the alphabet. And this one, what happened there? X only goes up to d, so this only has d inputs. And of course, all these functions are going to be all of 1 because of memorization. So then now you just take them, technically you add them together for your complexity, and which is the max, and it gets dominated by this thing. So at the end, the complexity is going to be this time, and for space, it's just d times k, I think, yeah. Because that's the maximal space used, like here or something like this. That's all I have for this one. The idea behind digit DP again is just brute forcing each digit in a good way. So as long as you're able to kind of break it down, the way that I like to do it is by breaking it down. So yeah, let me know what you think. Let me show you all the code at once. So this is one part of it. This is another part. This is yet another part. So you can pause, and this is it. That's all I have for this one. Let me know what you think. You could watch me solve it live with the 2 silly mistakes at the very end. Now, silly mistake. I knew how to do that one, but I think I was just not confident about understanding that problem, and then I have a silly mistake because I am silly. Oh well. People are getting this one, so let's actually do it. Beautiful. What's beautiful? The count of even digits in the number. Okay, I have to, and the number is divisible by k. Return the number of beautiful integers in the range low high. Okay, wow, people are already done with that one. Okay, and this is, and what's k again? Oh, divisible by k. Okay. So we want to do return the count of high minus count of low minus 1, right? But then what is f? No, it's just dp, isn't it? Feel kind of very quickly. Yeah, digit dp. I'm always kind of bad about it. We'll get it, but it's. Yeah, okay, yeah. That 5-minute penalty is stupid though. X is, okay. Okay, fine. is the number of digits. Okay, then first digit. X minus 1 digit left. First digit is I. Number of even digits in the. Okay, so it has to be. Okay, so if x y 2 should have at least one digit. Oh, I guess 2 digits. Okay. I guess symmetry actually, but whatever. Okay. People are much better than me at this stuff these days. Anyway, and then. Okay. Cool. Nope. Okay, so now we got all that. It's not done yet, I know. Just make sure I don't get any weird things. There is some weird things, like base case. So, oh yeah, wait. Yeah, whatever. Yeah. Right. Did I click on it? I think I clicked on it, but it's just okay. I don't need to wait for it, but let's try one. Oh, and K, which is I forgot about K, to be honest. Okay. Wow, people are really fast then. X is now defined. What? Oh, this is left. But I didn't even do that. Okay. 40 people got already. I'm not even close. I need to do unit things in a better way, but yeah. Okay. Man, the way I'm doing this unit DP, I need to tighten it up. I'm not gonna lie. I think the way I'm doing it is kind of slow. I mean, it's fine, but it's slow. Okay, and then now. First, I just want 1, 2, D, first, and 2, we add. -1. I think we don't need this as a parameter. This is a useless parameter. Man, 14 people got it already. Jeez Louise. Some people are so good. I still want mine. Do I still have a thing here? Yep. Right. And then now we have to add in the prefix. Right. Should be okay. Maybe I should have done it the other way. How many numbers with this? Prefix exactly. Okay. Now this thing. How many numbers have this prefix exactly? So point. This is kind of wrong. I need suffix of this. By definition, this should be a suffix. Okay, fine. I mean, I have to change some stuff, but okay. Isn't quite right though, is it? Because this digit should be 0, that's why. And this number can have what line is that? 83. Oh, right. Wait, what? X. Digits left? Oh no, I guess we don't need that. That's in suffix. Two, 1, 0, okay. I mean, the answer could be anything. I don't know, right? Like, I don't know what the actual right answer is, so. YOLO, I guess. Okay, let's see, 2, right after 3 to 31 and 16. 16 is the mod, so you have 16 is the possible number, a solution. And that's it, right? Why do I have 2? Well, that's unfortunate. Okay, so 31 is returning 2. Why is 31 returning 2? What? Does it put multiple times or something? Why is this putting so much? Oh, it's because I'm printing it twice. Okay. That means the prefix, right? So there's no 1-digit number. So okay. So that means that. So 1 is fine, and then now 3. Oh. What? So, okay. Huh. Really should get these much quicker. I'm a little bit sloppy today. Suffix is 1, that's true, so so far it's good, it should be good, but then this part is the G part. The odd number. Oh, I did 3-0. Oh, I copied and pasted well. Okay, so silly mistake. Hopefully that's the only mistake. Oops. Almost made another one there. Okay, let's remove my print statement. Okay. Huh. This is another one of those days, I suppose. 8, so the answer should be 8, 12, 16. Am I misunderstanding? Why is that not? Oh, 8 is not an answer. Okay, that's true. So 12 and 16. 18 is it? Yeah, that's right so far. Let's see. Also right so far. As expected, I suppose. 18.8. Okay, so why is it returning 3? Just also double check. Okay. Do I have another typo? I do because, oh man, come on, Larry. Wait, I'm doing this wrong. I'm doing it from the. Oh wait, no, this part's right. Okay. How did I make the same mistake twice? This is that kind of day, I suppose. Where's my other print statement? Do I have print statements? Oh no, I don't. Okay. Okay. Wow, really silly mistakes. That was a 10-minute, two penalty in the same way because I copied and pasted and too lazy to think about it. I really should have thought about it. Yeah, I mean, the copy and paste kind of hurt actually. I was trying to save time. Instead, I got 2 wrong answers instead of typing them out like I usually do. I'm actually very rarely copy and paste, but with this, and when I do, I make silly mistakes like this because I was trying to think through the problem versus, yeah. Oh, good job, Remix, top 24. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this problem, the explanation, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.